Hello and welcome back. This is a lesson now on optimization. And optimization just simply means if you're going to optimize something, you're either going to maximize it or you're going to minimize it. Quick refresher, where do these values exist? Well, maximums or minimums can either exist, well, we'll just look at maximums right now. They can exist here, here, or here. Now, what do these points have in common? Well, here you have a situation where you have a derivative of 0. Here you have a situation where your derivative is undefined, or here you have a situation where the derivative is not 0, it's not undefined, it's just at an end point. So these are the three situations where a maximum can exist, and likewise a minimum would exist as well there. So what we're going to look at as we optimize problems, we're going to need to find a function that's going to encompass what we're looking for. Then we're going to need to be able to do a derivative of that function. After we do the derivative of the function, then we can see, okay, we set it equal to 0. Is this a maximum? Is this a minimum? What do we have here? So let's just dive right in. The best thing I can do for you is to just point you to your book so that you don't have to copy these problems down. This first example is going to be minimizing distance, and it's page 220 in your book, and it's example number 2. So from this, well, my book's not cooperating. Okay, it says which points on the graph of y equals 4 minus x squared is closest to the point 0, 2. Now, let's think about what this looks like. 4 minus x squared, we got a parabola, and this parabola opens downward. And also, we have this point 0, 2. So we want to know what point on this graph is closest to it. Is it a point right here? Is it this point up here? Is it some point in between those two? It's not going to be down here because obviously anything down here would be further away than this point right here. But the answer is going to lie somewhere from here to here. And so let's just go for it. We are trying to minimize the distance. So we need the distance formula in this case. So our formula would be f of x equals to the square root of the distance between a point is the change in x's and now my y is going to be 4 minus x squared, so it's 2 minus 4 minus x squared. And all that's going to be squared. So from here, let's clean it up a little bit, I guess, first before we do the derivative. So it's going to be to the 1/2 power. So this is negative x squared, which would be x squared. All right, plus 2. All right, now distributing the minus in. So it's minus 4 plus x squared. I don't want to miss anything in here. And that would be squared. So we get x squared. 2 minus 4 is negative 2. So we have, I'm going to make this x squared minus And from there, f of x, I'm still to the 1/2 power, sorry. And x squared minus 4x squared is negative 3x squared. Right, in descending order. Okay, so let me make sure before we go any further that I have not missed anything here, because that would not be good. All right, so now we want to take the derivative of this and set it equal to 0. All right, so that's pulling down. And of course, we still got the chain rule here, so now we have to take the derivative of the inside. So it's 4x cubed minus 6x. Okay, pull this to the denominator, so it's 1/2 of x to the 4th minus 3x squared plus 4 to the 1/2 power. And this is going to be 4x cubed minus 6x. Okay, so from here we can factor out a 2. So we get 2x cubed minus 3x all over x to the 4th minus 3x squared plus 4 to the 1/2 power. All right, now we're not going to worry about where the derivative is undefined here. We're just going to focus on the numerator here. So let's factor out a x from this. So this would be x times 2x squared minus 3. So we want to set both of those parts equal to 0. So x equals 0, and then setting this portion equal to 0, we get 2x squared equals 3, so x is going to equal to plus or minus the square root of 3/2. And in the end, when you check these values, you plug them back into the actual distance here. And as far as the actual distance is concerned, the plus or minus square root of 3 over 2 is actually going to be what yields the minimum value of the distance. So you could go back, you could use your calculator, plug it into this right here, and when you plug in f of 0 and then f of plus the square root of 3/2 and minus the square root of 3/2, you'll see that these two, the plus square root of 3/2 and minus square root of 3/2, yields the smallest answer there. So that's the arithmetic involved. I'll have more optimization videos posted soon.